All right, example 5 here. We got 6p squared plus 42p plus 72. And first step, we got to factor out a GCF, right? So let's take a look at 6, 42, and 72. Do we see a common divisor there? Is there something that's kind of a common factor of all of those three numbers? And I believe 42 is going to divide by, 6. So the number 6 is just 1 and 6 or 2 and 3. So if any of these, definitely 2 since they're all even numbers. If it's 1, we don't do anything. But 3, just 72. But we're looking for the biggest one, and I think 72 also divides by 6. So the greatest common factor of all three of these terms is going to be a 6. So what we're going to do is we're going to pull that out first. Okay, so 6 times p squared for this is just distribution. Now 6 times what is 6p squared? Well, it's 6 times p squared plus 6 times what is 42p? Well, that's going to be 6 times 7p, and then 6 times what is 72? Well, that's plus 12. Okay, so getting that GCF out, we now see it kind of matches up with the rest of our examples where there's a 1 in front of our squared term. Okay, that 6 is a factor. It has to be there because all three of these things will multiply back together. We started with, if we drop that 6, we lose a factor of 6, and we don't want to do that. Okay, so now let's see if we can factor what's left here. P squared plus 7p plus 12. What times what is p squared? Well, it's going to be p times p. Now we need factors of 12, which are 1 and 12, 2 and 6, 3 and 4, and our meet in the middle technique kind of works there. 1, 2, 3, 4. Going back up. Okay, so now we need things that multiply together to get 12, which we've identified here, but add to get 7. And I see a 3 and a 4 right here that'll do that as long as the signs work. Knowing the last one's positive, okay, remember that means, so this tells us that we're going to use the same sign for both factors because that one's positive. Okay, since the middle's positive, that means they both need to be positive. Okay, so we go plus, plus, and then 3 and 4. And that is going to give me 4p on the outside, 3p on the inside. That will add up to get 7p in the middle. So very nice. Let's do this last one while we're here. This one's a little different because it does only have 2 terms, so we can think back to this one, but it's not quite the same 2 terms as last time. This one, just start with the GCF again. If you got to factor something, always look for a GCF. So 6 is, same factors as 6. 6 and 9 both divide by 3, so we're going to be able to pull a 3 out of this thing for sure. And then in this case, they both have p in them, so we'll actually be able to get one of those factors of p out as well. Okay, so 3 times what is 6? 2. Well, p times what is p squared? P. Plus 3 times what is 9? 3. P times what is p? Well, that's a 1. Okay, so we don't have to factor or pull anything else out for that one. Okay, so we just undistributed. We just found that GCF on this one, pulled it out front, and if you look what's left, we are not even degree 2 anymore. We're not squared anymore, so we're not going to be able to factor that down any further. So in this case, sometimes getting that GCF out is actually the factorization that we're looking to get to. So that is the final example. Pull the 3p out, common factor of 3, common factor of p in all terms, and then we can just kind of undistribute that, or what would we need to distribute that back into to get where we started.